Welcome to solverfy.
6.33. So we have two stars with equal mass maintaining a distance of 8 times 10 to the 11th meters apart from each other, and they're rotating about a point that's halfway between them every 12.6 years. And first we want to discuss why don't the two stars crash into one another because of or from the gravitational attraction between them, and what do the masses of the stars have to be? So the reason that they don't crash into each other is because of their circular motion. This is the same reason that planets continue orbiting the sun, for example. The gravitational force causes accelerations, which are changes in velocity, and because in this case, or in the case of planets orbiting the sun or whatever, the the change in velocity that it's producing is a centripetal force, and so this causes the direction of the motion to change, but not the speed, and it doesn't just magically suck it in to the gravitating object. Otherwise, the universe would not be a very interesting place. So now for this, if the gravitational force on one of the stars is providing its centripetal force, then we have gm squared over d squared is going to be equal to m v squared over d over 2, because this is the distance between them, and so that has to go into Newton's law of gravitation. But the v squared over r, since this is we need the radius and not the diameter. So like they're moving like this, they're both moving around this point, and this distance is d. Now we also know that v is going to be pi times the diameter divided by the period. So rearranging a little bit, we have 2 from down here goes up here, 2m times 1 over d, and then we have pi d divided by t, the period, squared. So then this is 2 pi squared md over t squared. And going back to over here, this is equal to the gravitational force. So solving this for the mass, we get 2 pi squared d cubed over g, big G, t squared. And so we find that each star has to have a mass of 9.6 times 10 to the 29th kilograms.